All right, so for 13.2, we're going to work on adding and subtracting linear expressions. Now that sounds fancy, but it just means an algebraic expression like we did in 13.1 with no exponent. So you won't see something like x squared or x to the fourth. You'll just see something like x. So our goal is to add and subtract these expressions, but really we're going to be adding them. Okay, so before we start tackling them, we want to do what we did in 13.1 and what we did when we subtracted integers. So we're not going to subtract. So anytime we see subtraction, we are going to eliminate it. So eliminate subtraction first. Okay, so remember we do that by adding the opposite. Okay, so that's the first thing you want to do. We can even call that number 1. Second thing you want to do, if you see any distributive property, you need to make sure you complete it first. So there's 2 different methods that we can use for adding and subtracting. I think you'll probably prefer the first method, but I'll show you both, and then you can choose what works for you. So here's what the problems are going to look like. So here's a linear expression, x minus 2, and it wants us to add another linear expression like 3x plus 8. Well, this isn't fancy. This is basically what we did in 13.1. They just slapped some parentheses on there. Okay, so let's look at what the number 1 thing we have to do is first, and that's eliminate any subtraction. So you may want to start by circling your subtraction symbol here. Okay, remember, subtraction will change to addition, and the 2, the opposite of 2, is a negative 2. So we're adding the opposite. Drop down the x, drop down the addition, drop down the 3x, drop down the 8. Notice when I rewrote it, I didn't include the parentheses because commutative property says we can add in any order, and this is all addition now. Okay, so let's look for our like terms. I have an x and I have a 3x, which means I have a total of 4x. If we look at our constants, I have 8, I owe 2, which means I still have 6. Okay, the second method is a vertical method. I'm going to just show it to you in case you seem to like it. So the first linear expression we were given was x minus 2. And the second linear expression we were given was 3x plus 8. Notice how I line up my constants and my x terms. Put an addition symbol on there because we're adding those 2. We still have to eliminate subtraction first. So my subtraction symbol would change to addition, and 2 would turn into its opposite, which is negative 2. So now we can add vertically. 8 plus negative 2 is 6. Drop down our addition symbol. 3x and x makes 4x. So you'll notice we got the same answer, just a little bit of a different strategy. Okay, let's try another one. Number 2. Parenthesis 4y plus 3, close parenthesis. There's our first linear expression. The second one we're adding is 11y minus 5. Okay, so job number 1, before we do anything, we need to eliminate our subtraction. Well, we only have one subtraction symbol, so subtraction changes to addition. The opposite of 5 is negative 5. Let's rewrite that though down below. So drop down the 4y and the plus 3. Drop down the plus 11y and the plus and the negative 5. I don't need these parentheses because commutative property says I can add in any order. So I have 4y, I have 11y, which means I have a total of 15y. I have 3, I owe 5, which means I still owe 2. So I can show it as plus, because these were all addition symbols, -2. You can also simply write it as 15y minus 2, because subtracting 2 and adding -2 are the same thing. I'll show you the vertical method again in case you seem to like it, then you can get the hang of it. So we'll put our first algebraic expression on top, 4y plus 3. We'll put our second linear expression underneath, 11y minus 5. That's how it was presented. We still have to eliminate subtraction when we use the vertical method. So I would change subtraction to addition and 5 to its opposite. And then we can just add vertically. So I have 3, I owe 5, which means I still owe 2. Drop down our addition symbol, and 11y and 4y makes 15y. Same answer, just a different method. Okay, I need a new page for number 3 already. Here we go. Number 3. Okay, so now we're going to show what it looks like when we have subtraction and the distributive property. So 2 times the quantity, 7x plus 3. And we're going to add the linear expression, -15x minus 6. Okay, so let's eliminate subtraction first. That's the very first thing we have to do. This isn't subtraction, this is a negative. We're adding the negative. So this subtraction changes to addition. The opposite of 6 is -6. After I've eliminated all the subtraction, I need to do the distributive property, which I see right here. So 2 times 7 is 14x. Drop down our addition. 2 times 3 is 6. Drop down the plus and the -15x. I'm putting that in parentheses just to separate those two symbols. Drop down the addition and the -6. I have 14x. I owe 15x, which means I still owe x. You can have a 1 here if you want. I have 6 and I owe 6, which means I don't have anything. So plus 0, we don't need the plus 0, so just -x or -1x. Okay, so now we're going to move on to subtracting, which is really no different because we're still eliminating all the subtraction first. Okay, so this is subtraction, but not really. Okay, so we have to make sure we understand one thing first. This is subtraction. Here's a parenthesis. This is a -x plus 6. Okay, so we have to get rid of subtraction and add the opposite instead. So this is really important. We're subtracting -x plus 6. So this subtraction changes to addition. And I need to take the opposite of both terms inside parentheses. So the opposite of -x is x. The opposite of 6 is -6. Okay? Then I can drop down the 5x and the plus and the 6. And then it looks just like it did. I really don't need these parentheses here either. Then it looks just like it did with addition. Okay? So if that is confusing to you, it's going to take a little bit of practice. Okay? Another way to think of it if I have my first expression, 5x plus 6 minus negative x plus 6, I can think of this as a 1 here. Remember, a 1 can be implied. 1 times anything is the same thing, okay? So subtraction would still change to addition, and the 1 would change into a negative 1. Then we can distribute the negative 1 to both the negative x and the 6. So negative 1 times negative x would just be x, just like we got here. And negative 1 times 6 would be negative 6. So again, however you want to think of this is totally fine. It means the same thing. Okay, so then let's work on simplifying this expression. I have 5x, I have another x, which means I have a total of 6x. I have 6, I owe 6, which means I have 0. So just 6x. Okay, let's try this again. Let's call this subtraction problem number 1, and we'll call this subtraction problem number 2. Okay, let's do 7y plus 5 minus parenthesis 3y minus 10. Okay, so let's get rid of our subtraction first. Okay, so this subtraction would change to addition. The opposite of 3 would be negative 3, so negative 3y. Be careful, this was another subtraction symbol. We'll deal with that in a second. Just drop this one down. And the opposite of 10 is negative 10. Okay, so I've kept the subtraction here, and now we have to deal with that. So 7y plus 5 can drop. Okay, subtraction changes to addition, and the 10, negative 10, turns into a positive 10. So if I rewrite again, 7y plus 5 plus negative 3y plus 10. Okay, so then I can work on adding my like terms. I have 7y, I owe 3y, which means I have 4y. I have 5, I have 10, I have 15. Okay, so let's try that again. On the next one, we're gonna practice subtraction to addition again. So number 3, the more we practice, the easier it becomes. Negative 10a minus 2 parenthesis 10a plus 2. Okay, let's deal with the first expression. So first, I have that I'm subtracting 2, so let's change that to adding negative 2. Okay, then I have subtracting 2 again, and I'm going to change that to adding and make that a negative 2. Okay, and then we're going to do the distributive property. So I'm going to start by just dropping down. I'll just keep the parentheses for now. Negative 10a plus, now remember this was a negative 2. Okay, drop down the addition. Now I'm distributing that negative 2. So, and again, I'll just keep the parentheses for now. Negative 2 times 10 is negative 20. A, drop down the addition. Negative 2 times 2 is negative 4. Okay, so there's a lot of parentheses going on in here, and in fact, we don't really need most of them because all of our symbols are addition, and we can add in any order. So I have a negative 10a plus negative 2 plus a negative 20a plus a -4. And I'm keeping these parentheses here just to separate the addition and the negative signs. So let's see what that looks like. I owe 10, I owe 20, which means I owe 30A. Drop down your addition. I owe 2, I owe 4, which means I owe 6. So -30A plus -6. Okay, let's try just one more together. Number 4. 4G minus 12 minus 4 parenthesis -8G minus 2. Oofty. Okay, let's get rid of these subtraction symbols. So let's just rewrite underneath right away. So drop down your 4G. Okay, subtraction changes to addition. The 12 changes to -12. The subtraction changes to addition. The 4 turns into a -4. Let's distribute that first. Okay? So actually, let's change this one first before we do the multiplying. We have to change all our subtractions. So subtraction changes to addition. The 2 turns into a -2. So drop down your addition symbol here. -4 times -8 is 32G. Drop down your addition symbol. And -4 times -2 is +8. Now we can work to combine like terms. I have 4, I have 32, which means I have 36G. I owe 12, and I have 8, which means I still owe 4. You can also write it as 36G minus 4, and that means the same thing. Okay, try it out in your classwork. Bye.